Title of the first section of notes today is Solving and Graphing. Absolute value. Inequalities. In this section, we'll solve the inequality and graph the absolute value inequality. First problem, absolute value of x is less than or equal to 4. To solve a absolute value inequality, the absolute value again you want isolated by itself, which in this problem it is. And one way to solve this is you can remove the absolute values. So we'll have x less than or equal to 4. And also the inequality less than or equal to we'll copy exactly as is to the left-hand side of the problem. And the number 4, we'll do the opposite of that, which is negative 4, that we'll put on the left-hand side of the problem. Now we have the inequality negative 4 less than or equal to x less than or equal to positive 4. From here we can graph the absolute value inequality, which again will be a single number line since we have a single variable. We do have two numbers in our solution, so we'll have negative 4 on the inequality, which I'll put on the left hand side, and we'll also have positive 4 on the right hand side. You can fill in some hash marks, so we'll have 0 in the middle. And from here we can graph with the open circles and closed circles. For the negative 4 value, negative 4 is less than or equal to x. Less than or equal to means it will be a closed circle above the negative 4. And for the positive 4, we have x is less than or equal to 4. Less than or equal to means, again, it is solid above the positive 4. So absolute value inequality graphs will have 2 points for the two numbers for the solution. We'll have 2 lines also. Each point can either go left or right, depending on the inequality. If we have negative 4 less than or equal to x, this means negative 4 is smaller than or less than x, or vice versa, x is bigger than or greater than negative 4. Bigger than or greater than would go to the right. Also for the positive 4, we have x is less than or equal to 4. X less than or equal to 4 means smaller than 4, so this will go to the left. When we have the 2 lines pointing towards each other, we can connect them, and the solution for this problem would be the numbers from negative 4 to positive 4, all the numbers in between, including negative 4 and positive 4. Second question and last question for the section. Absolute value of 6a minus 3 is greater than 21. And again, solving absolute value inequalities, the absolute value must be by itself. And to get our inequality so we can graph, we can remove the absolute value, which is 6a minus 3. Greater than 21 stays exactly the same. And again, the greater than symbol will copy to the left-hand side of the expression. And 21 we'll put on the opposite side, but we'll also make it the opposite of 21, which is negative 21. This equation we have to solve. We have to isolate a by itself, 6a minus 3. We can get rid of the minus 3 by adding 3. When you have a compound inequality like this, we'll add 3 to the middle section, we'll add 3 to the right-hand section, and we'll also add 3 to the left-hand section. Negative 21 plus 3 would be negative 18. The inequality stays the same when we add numbers to each side. 6a would stay the same. Negative 3 and plus 3 would cancel. Greater than, inequality stays the same. And 21 plus 3 would be 24. And the last step to solve 6a, to get rid of the 6, we can divide by 6. And again, we'll divide the right hand by 6 and the left hand side by 6. Negative 18 divided by 6 would be negative 3. The inequality stays the same when you divide by a positive number. 6's would cancel. We'll be left with a in the center section is greater than 4. So the solution to the equation or the inequality, negative 3 greater than a is greater than 4. Last part, we want to graph. Draw the number line. And we want the numbers negative 3 and positive 4 on the number line. I'll put negative 3 on the left hand side. We'll go up to 0. And we'll continue up to 4. To graph each of these, negative 3 is greater than a. Greater than means there'll be an open circle above negative 3. And a is greater than 4. Greater than, again, will be an open circle above 4. For the directions on the line, negative 3 is greater than a. Negative 3 greater than a means negative 3 is bigger, a will be smaller, or a is less than negative 3. Less than negative 3 would go to the left. And the second part, a is greater than 4. Greater than 4 would go to the right. So in this case we have our two numbers, negative 3 and positive 4. The solutions though are all the numbers less than negative 3 or all the numbers bigger than positive 4. The title of the last section today is Writing an Absolute Value Inequality. For these questions, we'll be looking at a graph and working backwards to write the inequality. First question, we have a number line with negative 4 on the left-hand side, 0 in the middle, and positive 4 on the right-hand side. Above negative 4 we have an open circle, and above positive 4 we have an open circle, and we'll connect the 2 points in the middle. Having the graph of this inequality, we can figure out what the original inequality was. To do that, we know it's an absolute value inequality since we have two numbers. So we can start with an absolute value. We'll have a variable, we can use x, and the number next to x that we'll subtract is the number that's halfway between negative 4 and positive 4. So halfway between the endpoints would be 0, so we'll subtract 0 inside the absolute value. The inequality, when the 2 points are connected in the middle, the inequality is always less than, and since they are open circles, it's not less than or equal to, it's just less than. And the number it's less than is the distance from the center to either outside point. So from 0 to 4, that is a distance of 4, so it will be less than 4. Simplifying this, x minus 0 would just be x, and our final answer would be the absolute value of x is less than 4. Second question, and last question for the section. Again, we'll have a number line This question will have negative 4 on the left hand side and negative 2 on the right hand side. The point above negative 4 will be closed or solid. The point above negative 2 will be closed or solid. The line for negative 4 goes to the left, and the line for negative 2 goes to the right. Same steps as above. We know it's a absolute value inequality because we have 2 points for the inequality. So we'll start with a absolute value. Using a variable, we can use x. We'll always subtract a number. The number we subtract again is the number that's halfway between our 2 endpoints. The number halfway between negative 4 and negative 2 would be negative 3. So we'll subtract a negative 3. When the lines point away from each other, that would be greater than. And since both points are closed, that would be greater than